All right. Welcome back. Another Shop Class podcast. Tonight's guest, very special guest. We're on the West Coast. We are at EV West. And today we have Michael Bream, founder, CEO of EV West. It's kind of like you think about hot rods back in the day, but if you think about hot rods as far as like adding electric equipment to your car, this is it's an option for hot rodding. You know, hot rodding will always be there, but this is another option. And I think the shop teachers would really appreciate the options because they still can do all their hot rod stuff. You can do suspension, you could do, drifting and all kinds of sheet metal, whatever you want, interiors and stuff. But now you might use a different motor. And so thank you for joining us, Michael. Welcome to the show.
Yeah, my pleasure. Thanks, Ron. Good to have you. I know you're in the next office over.
Yeah.
So this is fantastic. But dude, great to have you on the West Coast. Always love hanging out with you and talking shop.
So we always start with the first question that we ask every one of our guests, which is, did you have shop class growing up?
Yeah, of course. Right. I had and we talked about this off camera, but I'll fill in the guests. It's kind of ironic. My shop teacher was named Mr. Hammer, and I originally took wood shop with him, and then, kind of a smaller school. So he also taught metal shop, and I took that and learned how to weld. And then it was just the natural progression. As soon as I got my license in my car, I took auto shop, and that by far was the most fun. Being able to like park in the special lot behind the school, and third period everyone's going to talk about history and stuff, and you're like in your car like putting on a new set of headers or whatever. So to me it was just absolutely like the best experience I could ever have at a high school level.
That's awesome. Yeah. And it's funny because we hang out and stuff, but I've never really dived into your shop class years.
Right. Well, I was, you were raised on the East Coast and raised on the West Coast, and slightly different time periods and stuff. So yeah, we don't get a chance much to reminisce about our history. But I grew up just outside of San Diego here. My father actually grew up in West Hollywood, and he's from that same era as guys like Von Dutch and Rat Fink and all that. So he very much grew up in that era and did some hot rodding himself back in the day. Motor swaps, things like that, and he was an engineer. So he kind of, I think, appealed to the more technical side of that, and moved down here, met my mom in college, and had me, and I went to get a computer degree, an engineering degree from a local college here, the University of California, San Diego. And just always, been around cars pretty much my whole life, and really been fascinated with cars. And I'm not really sure. It's kind of like the chicken or the egg. Was it the shop class that got me into it, or was I into cars previously and that got me into shop class? And I think the answer really doesn't matter, because they kind of go hand in hand. Shop class is just a place to either develop a love of vehicles or to further develop the love that you already have, so, and that's the way I look at it. I really think, especially lately, budgets are tighter and things like that, so it's a lot tougher for schools to offer a lot of these extra classes, music, art, and things like auto shop, metal shop, wood shop, where you're actually working hands-on, you're actually developing skill sets.
Yeah. So let me share a photo. I've got a photo of you, your dad, and your son.
Oh,
it's cool because it's like three generations right there.
Yeah, just amazing. Yeah. And so I just absolutely love my dad. He was so instrumental. He helped us build our Pikes Peak car. And sometimes I feel like just having your father or a father figure, even a shop teacher, endorse what you're doing, it gives you confidence to carry it through, and you might not have been successful without that endorsement. So I consider myself extremely fortunate because I have a father who takes a lot of interest in what I do, and at the same time I have a son that takes a lot of interest in what I do, and to him it's fun. We get to build electric dirt bikes and bicycles and things like that he gets to run around with. But at the same time, he goes back to school on Monday, and they're like, "What'd you do over the weekend?" He's like, "Oh, me and my dad set an electric land speed record at Bonneville." So that's not your average thing for a 7-year-old to be taken to school. So that's fun because I hope to give him the same experiences that my father gave me when I was growing up. And I had those opportunities. He took me to the Baja 1000 and local races and things like that growing up. So I was kind of always around that culture, going to drag races and things. And it was just, he was always there kind of offering to take me to that stuff,
That's really cool.
Yeah.
We got two other shop teachers in the house tonight, and this is Tim Zevecki, and he's kind of on the northwestern side of Jersey. And we got Matt Bloomquist, and he's in Illinois. And what's cool is that so Tim is like a woodworking craftsman, but he does a lot of different stuff. And he's also got a Model A. He's into cars and whatnot. It's actually a Woody, so it's all wooded out in the back of this. How you doing, Tim?
I'm all right. How you guys? I haven't been here in a while, so it's nice to catch up with everybody.
Oh, absolutely. Yeah. Duke is in Hawaii or something. I don't know. He popped in for like a second, then he had to go because he got all the family obligations. And then Matt's here. Matt's from Taylorville, Illinois. How you doing, Matt?
I'm good.
Hey, Matt. Nice to meet you, bud.
So Matt's got a cool program. So they actually build a house from scratch every single year. There is no wood shop, like 4 walls and a ceiling. No, it's, they go get the land and then they bring the kids come out there for 3 hours and 3 hours. Is that right?
Yeah. 3 class periods. Yeah.
Wow.
Yeah. So it's like, imagine if you built a car from scratch every single year, but this time it's a house. So, and it's live. They sell it at the end.
Yeah. Well, I think, what you just mentioned is kind of like what the Formula SAE project is. So a lot of these students that get involved in shop stuff, they have this to look forward to. You go to college and you get on this team and actually build a race car from scratch, right? Tube frame construction from nothing, and then compete in national contests and kind of advance through that. So we work with a lot of colleges that have this program, and the Formula SAE program's been well known for years, but now they have an electric component. And because that's very progressive, I think it's attracted a whole new generation of engineers and fabricators and, automotive guys and girls to the genre now, because it's more technical, and it really just opens it up to a lot more opportunities. And also, I think when you work in electric vehicles, because it's more technology based, if you choose to exit the field, I think that you have a lot more options because now you actually have a technical background instead of just being a mechanic.
Oh, that's an interesting point. That's a really interesting point. Just
we have a celebrity in the house here. This is Gadget.
What's up, Gadget?
Doing some filming in the shop today, but for any of the listeners out there, if you have not seen Revenge of the Electric Car, and you are interested in electric cars, it's kind of like a prerequisite. It's like must-see TV, and you'll see Gadget, just really leading the way, showing people how it's done, talk about, just get in your shop and build it. He's just the epitome of that. So, a long time. Yeah. So, and thanks, Gadget. We'll see you, bud. Okay. And anyways, can't have him in here without giving him a quick mention.
Oh, absolutely. It's cool that you mentioned that. I remember watching Revenge of the Who Killed the Electric Car, and then Revenge of the Electric Car.
Right.
And there was a big chunk in the middle there, and lots of different things happened. Pretty cool. So he's kind of like a gearhead, and he like makes it happen. I think that the gap there. So the one thing that the Shop Class podcast, one of the things we're always trying to break the stereotype, and interviews like this help, is the idea that there's a track for college and there's a track for working with your hands. And I say, no way. You got to put those two together. And so you're someone that works with your hands. Absolutely. I've seen you build stuff. And you also went to college for engineering. So how would you explain the gap that needs to be bridged to, let's say, a guidance counselor or a shop teacher or someone listening to this, the importance of pulling that together?
I think it's human nature that we like variety, and nobody wants to just, be stuck in an office answering the phone or emails. And at the same time, you have somebody in the back of the shop, they don't want to weld all day long. So I think one of the things that we do is I like to put people more on projects instead of a skill. And that helps develop all of the projects. So what I mean by that is, typically maybe a shop would engineer and design something, and then that would go to fabricators. They would produce it, or it might even go off site to manufacturers. Then it would come back, and then you would have installers install it. So you could have, 3 separate departments working on something simple. And, what's neat now is a lot of the recent technologies, portable small CNC cutters, 3D printers, laser cutters, and the ubiquitous nature of design and CAD software now is just amazing. So you can get guys that maybe didn't have all the drafting and design skills, or maybe not fitment or tolerances. The software is going to help them. So now I've got guys that were previously fabricators, and they're sitting down in front of the laptop, like designing stuff in SolidWorks and Fusion and whatnot. And then actually being a part of that process, a part of the process of getting it manufactured and then installing it. And so kind of seeing that from the whole way. And conversely, guys that previously didn't have any fabrication experience, now they have all these tools and services like SynCut that kind of will build your parts. Now those guys can actually build parts that require much less fabrication now, because the parts come mostly ready made. And then those guys are going in and kind of learning how to weld and stuff like that. So I think one of the neatest trends that I've seen lately is this kind of like start to finish thing, because of all the technology and the products and the tools that we have available to us that we didn't have. I mean, literally just 10 years ago, this stuff was, and it might have existed, but, some of these machines cost $80,000, $100,000. We have a ferro arm, a 3D scanner, so we can take, let's say we want to match a pattern of a bell housing. We can take that, scan it, and put into the computer extremely quick, extremely efficient now. And again, 10, 15 years ago, that just didn't exist how it did now. And so now you're using a whole different set of tools. The quality's not the same. So it's like, it gives me all this optimism, because now we have these tools to do stuff that just I felt was out of reach before.
So just as an example, to pull out an example that you're talking about, is the ferro arm. So that is not just touching to get like a 2-dimensional pattern, but you could also scan.
Right. Yeah. And I should note, Ferro's a brand. It's like saying Ford or something like that. So they have several different products across the line. Originally, these were things that were just kind of reserved to bigger companies, building airplanes and stuff. And in fact, we bought our unit that we got was about $100,000 unit. We got it for like a tiny fraction of that price, because we got it directly from Boeing. And at the time, Boeing was upgrading some of their stuff to laser-based stuff. The touch-off arms, where you're actually touching the part, for us work really good, because automotive's real physical, so you get this big chunky transmission, or maybe an actual motor block on your scan table. It's not going to move around or anything, and you can get very, very accurate scans and produce the exact type of file that we're looking for to paramodel with.
Nice.
Yeah.
What would be in general? It doesn't have to be a brand. What's your go-to rapid prototyping? So if you have an idea, do you go to like a 3D printer, or do you go to like a laser, or what do you guys do?
Yeah, so it really depends on what we're doing. You've spent some time in the shop, so I know you see it. But, some of the things just in the last week alone, we were doing some bus bars that had some bends in them. So we wanted to make sure that we got the brakes just right with the radius of the bend to the thickness of the material. And so we 3D printed those samples. You've also seen they were doing the engine block battery pack, and they were kind of doing the bus bars. And so one of the first things they did is they used the laser cutter to cut out all the bus bars and make sure that they're going to fit. And that saves us money if there's an error or a mistake, or maybe even a designer would be more willing to kind of go in and give the design the extra effort, or maybe an extra revision, because the cost is very low, because you're just kind of cutting, maybe foam blanks that are inside the shop. Yeah, that's the battery box there that I was referencing. That is now in the vehicle.
Yeah, and so that's pretty cool. So that's going in like a classic, traditional longitudinal engine. So it's like where the engine would have been. There's a battery box.
It's like, is that an oil pan? You can kind of see.
It does the same thing. It kind of comes around. That's pretty cool.
So it's neat, Ron, because you and I earlier were talking about iterative design. We were John and I were chatting about SpaceX and them blowing up rockets, and they've got one waiting. And, on a low scale, this is kind of that iterative design where you have the ability in your shop to make sample parts or fitment parts to kind of dial in your computer files and your CAD work. And, to have that and to be able to do it at such a low cost that, just makes the entry so much easier for a lot of people that, we're kind of left out of some of the stuff because of the price of, the components and the tools and stuff like that. And now all of these things that I mentioned, you can get, student software for Fusion 360 for free. You can pick up used laser cutters extremely cheap. You can pick up ferro arms extremely cheap. And there's also services now. You don't necessarily need this stuff because now there's so many people that have it. If you have a bell housing, and let's say you want to make a part, you can look up a local CMM service that will do the the measurement for you and give you the file for just a fraction of the cost of the machine. So these are all things that just are so much more obtainable now. And I think what we're seeing is kids, literally kids in high school, like what you're teaching, coming up with designs that look professional, and they're using these tools to the best of their benefit.
That's so cool. Let me, I wanted to show you some of the stuff that that Matt is doing. Now let me ask you a question, Matt. When you're coming up with the site plan, do you do anything iterative? Is there a design for the site plan, or is it, or I know he's been working with an architect because they do a lot of like super efficient houses as well. Matt, are you doing iterative design, or is it more just the kids get to do the on-site stuff, but then you might do iterative in the future?
So, like when you say iterative, is that like on the fly?
Well,
Or
try it
as you go.
Try it out. If it doesn't work, you could try another version. Almost like
design build.
Yeah, I think it's more that philosophy that sitting around and talking about all the features of a house would be best done in a house just built, right? And kind of like, how are we going to do this better next time? So typically when people are talking about iterative, they're talking about bringing it to completion. Really the best example is the SpaceX. They're on Starship number 24 now, and maybe only 5 of them have flown. So they've built entire rockets, and the purpose of building the rocket wasn't actually to fly it. It was to learn and refine their manufacturing techniques, and so
Gotcha.
I guess your example of that, Ron says you build a house once a year. So I guess, what lessons do you take from the previous year's build that you bring into the following year?
Yeah, absolutely. Well, so for us, we take a floor. So an architect named Steve Basic, who's popped on the show and stuff with us a few times. He's been generous enough to provide us with like floor plans now for free, which is awesome to, have him give us a whole architectural service pro bono, as busy as he is, would be kind of a big deal. So the good thing is, so what he does is he'll give us the floor plan, and then so actually what I'll do is I'll collaborate with people and companies that want to work for us, and that kind of dictates what materials, what wall assembly. Now we have our goals as far as energy efficiency and stuff. Now with the students, sometimes it's just straight, this is what wall we're building. We're going to go build it, and there it is. And then once that wall's done, the next house comes around and we start that process over again. Now, I really don't get to do that much with the students just because it turns over. So I don't necessarily have the same kids. Sometimes the same kids that framed last house could frame this house if it times out right, but it's kind of rare. One of the things we're going to start doing with the prerequisite class is have them do wall assembly mock-ups of different wall types that we could potentially build. So when they come into the class, they could potentially be part of that process unofficially because, they did different wall mock-ups in the shop classroom, and then they'd come out to the job site and potentially build one of theirs that they mocked up, or some kind of version of it. But yeah, with products changing and everything, I mean, we're always kind of learning. We're always, we build this one. And it's same thing with manufacturing that they do. Once we build it, it's like, okay, what are we going to do next time? Or what will I do next time that makes the process go faster or makes me able to teach it better? I mean, I'm just as much into the lean side of things as you get into as a manufacturing.
Yeah.
It's a little different, but the principles are all the same.
You're leaving out the best part, that they actually test the house for what's called air tightness.
Yeah, blower door. Yeah.
Oh,
Yeah.
wow.
Mike, have you ever seen one of these? Do you know about this?
Is that just a really big turbo?
Yeah. Okay.
Yeah.
So this is super cool. This is like you get to pressurize the house or vacuum the house, and then based on how
amazing. Yeah.
And
That's amazing, because I live in a house built in the 50s, and I know it would fail this test miserably, and I know it's directly related to how much I have to heat my house in the winter.
Yeah.
I've got a question for you, Matt. So you said, I'm fascinated by this. You guys actually build like a single wall in your shop on campus.
So one of the things we're planning on doing, because there's a prerequisite class, Intro to Industry, that they take before they can take building trades that you get into as a junior senior. So one of my former students that helped build one of these houses is getting hired on to teach, which is really cool. So what he's going to do is he will work with the students and they'll build, let's say, like a 4x8 wall section.
Right.
And we may build one that's, say, code minimum, then step it up with, exterior insulation, or maybe use things called the T-studs that have their thermally broken studs. I mean, we could show them how to use build walls with straw bales. I mean, there's all different kinds of things going on in the building industry to make things more sustainable, reduce carbon footprint, all that good stuff. Because ultimately one of our goals is, you guys are into electric cars and stuff. We pretty much we don't hook gas up to our houses anymore.
Amazing. Yeah. They just passed legislation locally here. New houses can be built with gas. I think that's a step in the right direction.
I didn't know that. That's amazing.
Yeah. They're, they try to be progressive out here. The neat thing is, on the surface, you think that might be a problem. And then you realize it's really not a problem at all. Everything that we need it for. I mean, maybe the chefs, I know that people that cook, they like gas, but other than that, electric water heaters and all the other appliances in your house. And, once, I think it's interesting now. I feel like we're in a cost where we kind of saw peak electricity because a lot of it was produced expensively. And now with so many more sustainables going onto the grid, I feel like, now's the time to kind of look into these technologies to really reduce the cost of energy in your own home, and
we've even hooked up a hybrid water heater.
Oh,
so
wow.
It has a heat pump,
Wow.
And it's supposed to only cost approximately like $10 a month for hot water. Now our goal for one of the next houses is to potentially be net zero. Now granted, you never, as far as net zero goes, it kind of depends on how the occupants use the property, use the house. But we might actually be putting solar panels on our next house. I'm talking with some people, because the thing is with us, for solar to go solar, technically we're a spec house builder, right? We build it with no customer. Well, as a spec house builder, you're not going to throw solar panels on because you get no return on the investment.
Yeah.
But so we got some connections that we might be able to get that system.
And I think that's
donated,
changing, maybe a family that just has combustion vehicles might not see it as a net positive, but we are moving into an area now where you're seeing more adoption of electric vehicles, and you might actually have a customer specifically looking for solar. I know in my situation, my wife and I both drive electric cars, and we have an absolutely massive solar system on the tiniest house ever. It's kind of funny. 44 panels on a house that's smaller than 2,000 square feet. But that's, I want to drive an electric pickup truck. I got my Ford F-150 electric order in. And right now, all our family has ever driven for the past 8 or 9 years now has been electric. So it's one of those things that seems unattainable, and then you kind of do it and you realize, hey, that was pretty easy. And then here at the shop where Ron is right now, we did a 18 panel system on top and did a power wall. And so all of our employees that drive here now can charge their car for free. So now basically it's kind of like, imagine going to work and getting a job and they say, hey, Matt, we're going to give you free gas every day, just as a bonus. And that's kind of where we're at now with, electricity and how deliverable it is just over a simple cable or a wire to the vehicle. So it's really a new thing. And I think we're, pretty soon you're going to see more and more of this at schools. I'm not sure about East Coast schools, but West Coast schools just are in this major trend right now where all their parking lots, they're covering them with solar shades. And it's win-win. You don't get all the heat and the sun on your car all day. The school makes money, and it kind of shows at that student level, it shows the students like this is actually what's possible, and now in a very, very complicated world where we're not energy independent and we are sending money to foreign nations that might not be so savvy. And I really think the youth, this weighs on their mind a little bit more than people who are older. And so this is really kind of like going to be their situation when they get older. And so I think that early adoption and showing them early on, because, to borrow Jay Leno told it to me, but the original quote comes from Mark Twain, something about we all love progress, but we just don't like change. And we got to get over that. We got to be able to accept some of these changes to progress, but sometimes that change needs to occur over a generation. And so these kids, they're not going to have all these old heavy hangups and just weird oddities about oil and combustion or this and that. They're just really going to embrace it. They're not like, the rumble of a V8 really isn't nostalgic. My kid grew up in the rear seat of a Tesla, and that's what the new generation is going to be like. And it really gives me a lot of hope because you really, when you start talking about sustainability, and especially for motorsports, if you want to continue racing, if you want to continue under this threat of what's carbon neutral and what's politically correct, if you still want to be there for the sake of progress and innovation and competition, all those boxes are checked. And the older generation is missing the nostalgia, but the newer generation isn't. And I think we need to seize on that and just really champion these technologies, really for the younger generation, for the next generation of kids to, and then, I guess ideally my kid grows up and nostalgic to him is the sound of my M3 race car going up Pikes Peak. That would be pleasant. Yeah.
And EV West does a good job, man. These cars, they haul ass. It's great. If you go through if anyone's watching this, or you go through the Instagram, there's these little clips of them doing burnouts and whatnot. It is not a performance cut at all. This is a performance upgrade, 100%. I mean, these things kill. I've driven some of these cars. It'll scare you. I'm not qualified. It's unbelievable how fast they are.
I should mention to the viewers, we're obviously an electric car company, but we're not here for the environment. We started back in 2009 simply because everybody was focused on saving gas and saving the environment. And to me, a car guy, like at the time I was literally racing gas cars in an endurance race series called 24 Hours of Lemons. You might have heard of it. It's an absolute blast to do. Me and some friends were racing in lemons and just having a real fun time. So my first experience with electric cars was horsepower based. I saw a dyno chart on a motor, and the single 11-inch motor was putting out over 800 foot-pounds of torque. And it was just mind-blowing for me. And, at the time we were working on our E30 is what we had, a BMW E30 with an M20. And we were doing everything we could to extract every little, piece of power out of the thing. And I wanted, back in 2011, just wanted something a little bit more challenging, and sat down and designed and built an actual hill climb race car. And we raced officially Pikes Peak in 2012, and first year entry, rookie driver. And we were able to beat the Yokohama car. We beat Monster Tajima and the GoPro car. And we did all these things that really, I completely credit electrification, giving us that potential and giving us that power. to build something that was as competitive as some of these other cars that had been out there, with basically multinational companies sponsoring them and a multi-million-dollar race budget and things like that, where we were literally doing it just on a shoestring budget. My dad and my wife were our pit crew, and so I think that was my first experience with it. That this is so empowering and really has a place in automotive, racing and competitions. And it was that segment of performance I felt was very being underserved, right? There was really no one out there talking about performance. Everybody just wanted to talk about saving money at the pump, which is just so boring to automotive guys. That's for the financial guys, And so we just really wanted to build stuff that was fast and take advantage of a technology that was new and maybe a little misunderstood, and I credit that to just basically, building the electric instead of building another typical combustion vehicle.
I like that you say all that, Mike, because obviously, I approached the house building with the same idea.
Consensus, yeah.
Yeah, I'm all for saving the planet, doing better, things like that. But the idea of just building a tighter house and a more efficient house and a better, insulated house that really doesn't cost much more, but it performs, like you kept saying the word performs, performs so much better than all these houses that are getting built that are just energy hogs and everything. And that's what really excited me about it, was the fact that we could, and take high school kids to do this. Was, that was kind of the fuel for me. So that's where I get all excited about all this and learning. Because, heck, even if electric was expensive, if you're using so much less of it, it could still be less expensive than heating your house, fuel or whatever.
Right.
So it's, and the idea of, I just think it's really cool too, that the idea that you could throw, say, solar panels up on your roof, you could heat, cool, cook, clean everything in your house, charge your cars, and sometimes produce more and even make money, if you have that program set up where you live, get rebates and stuff. I just think that's really cool that your house can perform like that.
It has a performance rating, right? I guess the analogy for you is you get these students and you're like, hey, let's build this mock wall. And then they get to actually experiment a little bit, like with the construction technique or maybe materials. Whereas, I guess the analogous flip side financial would be, okay, take this 4x8 section that you just built and give me a cost analysis. That's boring. But I think that for students, that would probably, I'd imagine, give them a ton of pride to figure out a unique way to maybe, do a joist or something in the construction that saves some money, or an effective method to reduce the amount of copper that you run for the electrical, or just anything like that. I think I could even see myself enjoying that. There's a lot of pride when you engineer something and you kind of get it done.
Yeah. We're speaking of low, using less copper. We're actually running all our ceiling lights and fans will all be ran off of low voltage. So the whole house.
Oh, cool. Yeah. Doing a small
low
DC
voltage
circuit. Yeah. Okay.
Yeah.
Going all the way back in time to Thomas Edison. The first circuit, I just read a fascinating book called Electrifying America, all in the history of grids. And, the first grids that they did were actually used to sell office space. Like, electricity was so new and so foreign. But at the time, if you had an office building, everybody in that office building used an oil burning lamp. And so the first circuit they built, they just basically put lights in all these offices. And, they weren't trying to sell the electricity. They were trying to sell basically an office with a lamp that you didn't have to keep filling up with oil. And, we know how that turned out. It was wildly successful and went from there. So, but I think that's neat. You're kind of going back to this little micro DC grid in the sake of efficiency. That's fantastic.
Matt, did some of your students made a wall assembly and you guys won a prize? Like, which one is it?
Go down. It should say House 28 right there in top 4. You're right there. Yeah. House 28 wall. So we did the wall assembly contest again and we got 3rd place. Which is pretty good for high school kids, considering you're also going against some college kids and everything else in this. So
this is, there's no, like, the rules, they don't actually have to build this, but they can calculate all the R ratings and the efficiency of the wall, and then I guess the cost as well. And then it's judged by the best architects in the the efficiency, like passive house genre.
Building science.
Yeah, building science. Which one is it? Is it number 3 or number 4 here?
No, slide up, I think, or slide down. There it is,
Oh,
number
here
6.
Here we go. So Taylorville, Illinois. That's you. And and then so based on your climate zone, which I didn't realize there was an actual climate zone, and they rate the whole country. And then also, and now this was done by your student, right?
So, well, yeah, it was all submitted. That's the wall that we built. So we submitted it on behalf of the class this time. Now, last year, Thomas actually did his own wall and got into the Final Four as well.
That's cool.
So this design you guys have actually built then?
Yeah, this is the wall. Yeah. Pretty much, we didn't design the wall for the competition. We took the wall that we built and just submitted it into the competition.
That's even better. That really is. We do a lot of that sometimes here. The big joke in the shop is CAD, is cardboard aided design. And, because, early on, I graduated computer engineering in 93. So I'm a little bit old school. But one of my early professors that I really respected a lot, on the first day of class, he said, look, if you do something with the computer that you can do quicker with a pencil and a piece of paper, you're an idiot. And it really resonated with me, because you don't want this attitude that you just got to go to it, or like in your case, teaching the students you can't build a wall without designing it. Sometimes your best creativity is going to be, we were in that conversation earlier about using your hands and the variety of your skill set. But I think, going out there and doing that, we do it in our shop with CAD, we'll make something, but then we'll actually need to replicate it, in production. And then now we're reverse engineering. We're taking something that was designed in the shop and we're trying to quantify it, measure it, and actually put it in the computer. Probably like what you guys did. Like, we built this great wall. Now let's get it judged. And then you have to build the computer model, That's fantastic.
Yeah. So, and it's really wild because they've put a lot of effort into this. This is like a grid. And then these are all the architects and builders throughout the country. And a lot of them have like their own TV shows and whatnot. And so you could be in high school or college. Can you have a company and enter here, or does it have to be high school or college?
No, it's this. Since Connor took it over, it's completely student. It has to be student based.
That's good.
And I believe that it's North America, so Canada and US. Yeah.
Okay. And so it's pretty wild. So they get, and especially when we get the Canadian builders on here, I mean, they're dealing with a crazy climate. I mean, I think New Jersey's cold in the winter. They're cold way more often. So their efficiency, they take a lot of pride in their efficiency. And they've got these cool, like, new products, like the T-Stud is a cool thing. I feel like you'd enjoy seeing that. It is a thermally broken stud. So the wood is not transferring. Like, if you got the wood like this, it's not transferring energy across, because one of them's like this and one's like this. And then there's a truss in between, and they are structural, but they don't transfer energy as much. And I can pull that up.
That's fascinating. I just recently had a thermal camera in my house, and I just kind of pointed it at the walls. And the most fascinating thing to me that I didn't realize is when you're in a house and you point a thermal camera at a perfectly just blank white wall, you'll see the studs show up on the thermal camera.
Bam!
And when you said that thermal break T-stud, I was thinking of that because, again, I have a house constructed in the 50s. There was no such thing as a thermal break T-stud back then,
Yeah.
But that just sounds fascinating to me. And I could, with the FLIR thermal camera, I could visualize the heat on the outside of my house literally coming through the studs into my drywall. And you see these, lighter strips and the thermal imagery of the heat coming in. And wow, that's just fascinating. I don't think I can restud my house. So is that wow, that's fascinating.
Mm-hmm.
Yeah,
let me get you a better. Here, this is a better.
Oh, go ahead, Ron, while you're showing that. But we use a FLIR. We have a FLIR thermal camera also. So what we do is with that red blower door, especially when the temperature inside outside is got the delta T's larger.
Yeah.
We'll turn that thing on, whether pressurized, depressurized. Well, there's a thermal camera image of the
There you
T-stat
go.
actually.
Oh, wow. Cool.
So you can see that purple
Yeah.
break inside there.
Yeah.
But
But you do see them lighter colored, so they are, there's heat in there. Oh, that's fascinating.
so now that one wasn't a true like transfer of heat show, and I was just having some fun on that. But
Yeah, just maybe
we use the thermal cameras to find air leaks. So you'll go around and you go look around in areas, and if you can see, we call it ghosting, where the cool air from the outside is coming down the warm wall. Then you can go up there with a bead of caulk it, and that it goes away. And then you go over to the blower door, and if you do that enough times, assuming there is enough leaks, your blower door score starts going down, which is good. So it becomes really fun. It becomes a game for the kids, and then that's where they start understanding the whole purpose behind air sealing and adding these extra caulks or tapes that we use and stuff. But yeah, it's the same thing too. Like you said, for us now, we can go around to the outside of our house with our exterior insulation, and especially with the T-studs this year. And I'm not saying we couldn't find our studs from the exterior, possibly, but it'd be very faint.
Yeah. You said a couple of things in there that I find very interesting. One was the delta T. For the listeners, he's talking about the difference of temperature, say inside to outside, and the bigger that gap, the more difficult it is. And we are in a time. I live down near the beach, and our whole entire community is pretty cool. And over the last 20 years, all of a sudden, we are experiencing these summers that are so hot. Now a ton of homeowners are retrofitting air conditioning. And these are in homes that they never needed it before. And that's just kind of a symptom of this growing delta T. And, now the hot climates are getting hotter and the cool climates are getting cooler and more extreme. And I think you're going to see more people like kind of looking into what you do and seeing a demand on that kind of engineering and design process put into insulating and the efficiency. I love actually the performance of your house. I love that word. That's just fantastic.
There's a really good group movement happening in this space. So they call it the Passivhaus Accelerator. This is they do a lot of meetings and deep analysis of the costs and the payback and why you should and how to do it and finishing. It's not just the design, but like you can't have a builder just take a nail or a screw and just go right through your layer that you're like a water layer or something.
Yeah. Right.
So, and you got to anticipate this stuff because you're not going to be on site all the time. I've learned a lot about energy and moisture from talking to these builders because, coming from basically like a car guy kind of point of view. But to me, it's all the same. You're just talking about energy. You're talking about different materials, design, testing it out. I love verification. That's great.
Yeah.
And my favorite.
Matt's got me all fired up, dude. I'm going to be running around the house with the FLIR camera and a tube of caulk tonight. Like, I didn't think about, you're just, clicking off these ideas. And I'm like, oh, yeah, if you have a draft, that's going to cool the surface temperatures around it. And that will just show right up on the FLIR. And I never really got into that detail. I was just kind of shooting it at walls and stuff like that. But I'm going to sleuth around.
Go into your
performance leaks.
Yeah. So I was working on, and I didn't put the blower door here at home up, but in our bathroom, we were getting some musty smell, but there really wasn't mold. Well, there's an air leak inside our wall, probably where the wires go up from the switch up into the attic. And there was just enough warm on these really hot days we'd have with the air conditioner on. There was enough warm attic air coming down because the warm is going to move the cold.
Right.
And it was coming around our switch, not enough air that you could really feel, but you could smell it. So I went around and was caulking because when I did the addition, I did not know enough about air sealing. I mean, we built well, but I didn't know this much. And so, yeah, I was air sealing. So literally I found air leaks by smell this time and stuff. I should have brought the camera over, but yeah, it's one of those things. Once you get going and once you start learning more and stuff, But it's building new is obviously the easiest time to catch the do stuff to stop the air leaks. Once you have a house built, it becomes a little more challenging. But and then the other problem is though. So the good side is you stop these air leaks and all this, but then the bad side is now you can hold moisture into your house because you just lost drying potential sometimes. And so it's one of those things where sometimes doing good, you got to fix the next step that comes along with it and stuff. So it's been really interesting, diving down the wormhole here and getting deeper into stuff. But yeah, once you get going on things and start learning about things and, pulling out the thermal imaging camera and getting into air leaks, it becomes really interesting and kind of fun to go on the hunt and, like I said, make your house perform better.
Yeah. I have a friend who kind of works on latest technology and energy efficiency, and they recently put one of these water condensers on top of their house that uses solar panels to basically, kind of run an air conditioning system that you're condensing the water out of the atmosphere. So it's a distilled water, and it creates something like 10 liters of fresh water every day. Is that something you guys look at for doing like the highly efficient home builds and kind of those other technologies I'm seeing more and more? In fact, we were just recently at a thing where they're taking this technology now and they want to put it in cars. So when you're driving around, your little water bottle is actually getting refilled from water from the AC. Yeah, it's just mind blowing. And they patented this thing that fills the bottle from below. So you put it in your center console and you're just driving around town.
Oh, that's awesome.
Your water bottle is literally filling up with water while you're driving. And so I'm just seeing this kind of technology, and I feel like it's something that, you almost need to incorporate into a new home. So you have a separate plumbing for your pure drinking water, and then maybe the rest of the plumbing is for showering and stuff with reclaimed water or something like that. And water out here on the West Coast especially is a really hot topic right now. We got a couple of big lakes you might have heard of that are about to go away, Lake Powell, Lake Mead. I mean, just mind-blowing to live 50 years with these lakes in our backyard, and now we're probably going to see them dry up in the next decade. Is just really, really hard to wrap your mind around. Yeah.
That's wild.
Yeah, we haven't gotten into that yet, but that is pretty crazy. I think the craziest thing I've just started on BS Friday, Ron, Mark William them had this company on.
That's Building Science Friday, but they call it BS Fridays.
Yeah, Building Science Friday with Dave Cooper.
There's a lot of people into building science. It's really cool.
What blew my mind was, how we have radiant heat. You have tubes in the floor or ceiling or whatever. Well, this company does radiant cooling. And it's the same kind of idea. And it's crazy. You put these panels up in the ceiling, they just click on, and then you cover with drywall, and it will cool the area.
Wow.
So you're not using air conditioner, you're using radiant cooling, just like you use radiant heat. I was watching it. It was a great episode on BS Friday by Dave Cooper. They just did a couple weeks ago, and we'll have to get them on the show too, Ron.
Oh yeah.
I'm hoping I can connect with them and maybe put that in the house too. But mind blowing. And the thing is, their system's very installer friendly, and retrofit friendly, kind of thing. But I was like, it just blew my mind that you can cool the house kind of that same way. The technologies are crazy.
Yeah, I think we'll see more of this too with the heat pump technology and stuff, just really focusing on that, efficiency, really. Yeah,
that's super cool. To pull in, to circle back around and pull in Tim a little with his Model A. Michael, has EV West done any Model A's or something like that I could pull up or think about?
Nothing that we've done here in our shop, but we've been, directly involved in a lot of those types of classic builds. If you don't know, a Model A has manual brakes. It's literally a rod from the pedal. And so a lot of these technologies, you can use regenerative braking, so you can put an electric motor in there and have brake assist come from the motor. And so there's some neat things that you can do with electrification of an older car that play to that car a bit, being able to limit your torque, program your slew rate and your acceleration rate to all stay within the limits of a car that has wood and spoke wheels, right? So it's really neat. And from that standpoint, we've worked closely with customers that have converted early cars, basically anything with a wooden floorboard. And even outside of that, just recently they've remade Perry Mason now. I think it's a show. I think it's on HBO now. And this was a show that used to run, way back in the day in black and white.
I heard the name.
So they're driving all these 1920s cars around, and to make it easy on set, they electrified all of them, and so that makes it really easy for them. Yeah.
That's
Pardon
pretty
me for a
cool.
moment.
Yeah, no problem. Pretty cool stuff. This is the future is small garage companies that, and he started with just a garage. Before that, he actually had we didn't get into it, but Michael started a skateboarding company called Gravity Boards. And that's how he got started. And he just got into car racing. And then he's like, well, can't I go faster with electric? And so they, got into electric. I was just saying how you also started a skateboard company as well.
Oh, yeah. Yeah.
I really like the idea that these new ideas are really coming from, garage, like a passion for something, and then it grows into a customer service thing.
Yeah.
And so it's pretty cool that it comes from that.
We had particularly lucky timing, I guess. You can't really choose your timing well, but we were kind of on the cusp of this movement of, it's tough because you say electric cars and it means so many different things to so many people, but I think a majority of them think of it as a necessity. Like we're mandating, like you got to drive this boring car because we got to save the world. That's not my job. If you want to save the world, go buy a Prius, or actually better yet, just walk to work. Don't drive. That's environmentally friendly stuff. We're jaded, because we have these corporations, greenwashing us, saying, hey, buy this new car and you're going to save the planet. And without even analyzing all of the energy that went into building this new product, and maybe there's a better way of doing this, so when you're talking about, trying to move away from oil and all that, that's really for automakers. That's for Tesla. That's for Ford. We're here for the car guys that want to have fun while they're doing this. Like we understand that our byproduct is you've cleaned yourself up, but that's not our main product. We're here to sell performance in the same way that someone's trying to sell you a turbo to put on your V8 to make your car go faster. We're doing the same thing. We're saying, hey, you can actually ignore all this other stuff and just focus on improving your experience in your classic car. And you really can be that selfish because, again, the byproduct is this kind of carbon neutral or carbon free vehicle. And I think if you focus on that, you're missing the point. You're probably a little boring, and you're not really just getting all that you can out of this technology, because it's a really fun time to play with this stuff. I mean, for any performance guy to look at like a run sheet, a 0-60 on a Tesla Plaid, for example, 1.99 seconds. I mean, this is a car that's a luxury sedan with a child seat in the rear of it, and it's beating every Bugatti, F40, F1 on the planet, and so we live in this fascinating time, and the best is yet to come, right? These are cars that are all on the street now, and wait until the hypercar companies, wait till Koenigsegg and Ferrari and Lamborghini are making pure electric cars. They could probably make you black out just from accelerating. So yeah, it's gonna be fascinating. You look at some of these things, like I love the competitions that don't discriminate, right? So what I'm talking about is like the Goodwood Festival of Speed over in England, or the Pikes Peak Hill Climb. You go, a gas car goes, a steam car goes, it doesn't matter. They just don't care. We're talking about elapsed times running up the mountain. And now if you look, the last couple of years, the fastest time and the overall record at Pikes Peak has been set by an electric car. If you look at Goodwood, here's a venue that Formula One cars entered that race. Literally the quickest accelerating cars in the world. And that record right now is held by an electric car. They actually made an electric fan car with an electric ducted fan to suck it down to the ground and give it extra, downforce basically, and hold these turns. Yeah, there you go. The McGurky car. This is just the most. This just tickles me to death. This is one of the coolest, funnest things happening in cars. And when you look at this footage, I know it's a little jittery because we're on a low bandwidth, but when you watch this footage, it looks like it's been sped up. It doesn't look like it turns so quick and redirects directions that it just does not look real. And if you're a car guy and that doesn't get you excited, check your pulse, because this is just, this to me is exciting. And I think some people are, oh, well, it's not gas, it doesn't rumble. You're focusing on the wrong stuff, man.
Yeah. Totally.
This is, here's a car that literally is beaten Formula One cars. And that's something that most of you guys could probably build in your garage.
Yeah, this is wild. And it's complicated too. It's they're using the fans. So and people need to dive into that later. That's all about vacuuming the car to the floor. But not
and if you don't know the history of the fan car, definitely Google Jim Hall fan car, read the history of that, and then go into a Google on the recent Goodwood record holder. Oh, is that your car there, Matt?
Yeah, this is Tim's car.
Tim, I'm sorry. Yeah.
Yeah, that's my car. My grandfather built that car.
I should have noticed there's no thermal barrier T-studs on it, so it's not Matt. My bad. Wow, that is really cool. Yeah.
Oh, you went. It was like a rally or something, right?
Yeah, we went up. There's this thing in Reading, Pennsylvania, Duryea Drive, where Duryea, he used to test his cars going up this hill, and if his cars made it up the hill, then they were able to be sold, and if they didn't make it up the hill, then they had to be brought back down and fixed and tweaked, and then went back. Back.
Was he a dealer or a manufacturer?
No, he manufactured. He was a manufacturer. He built the Duryea automobile in Reading, and then he was out in I think California or Michigan or something.
That's cool.
He made those cars. And that was a tour we made up to what's called the pagoda. There's a pagoda at the top there, and we went for a tour up there, which was.
I love how in that photo your gas tank is like right in front of the firewall, like basically sitting in front of the windshield. And I don't know if anyone caught it, but your fuel gauge is a floater on your dash, right?
Yeah,
I love that. Yeah, how far we've come.
Literally, like you unscrew that piece and you can put your fingers in the gas tank.
Yeah. That sounds super safe.
And there's literally like a bobber on it.
Yeah. And you have your fuel mixture on the steering wheel, right?
Yeah.
Or advance maybe, or is it mixture or advance?
It's Spark. It's Spark Advance. And then you have the throttle. So that car actually has cruise control, believe it or not.
Yeah, right. Yeah.
Okay.
Because you can pull the throttle lever, and then you can take your foot off the gas and you can just go cruise. You don't have to step on the gas.
That's cool.
Which is so if you're doing a highway, it's great. You can just set it and forget it and just cruise around.
This is some of Timmy's work that with the students. This is student work. And they do bowl turnings, but they first glue different types of wood together.
Yeah,
it's surprising what the kids can do, right, Timmy? This is a kid's work, right?
Yeah. This is this was their first experience on the lathe, and a lot of times what ends up happening is sometimes they try to get a little more overzealous than what they want to be, than what I want them to be, and with the whole COVID thing going on, I changed some requirements on some of the projects, but these are some of the projects that the kids came up with, and they take home.
Cool.
Yeah, he does a good job empowering the kids. Here they are.
Yeah, I saw some cornhole boards in there. Ron and I were just playing that. I looked at making my own, and now the cost of wood is so expensive, it almost doesn't make sense. I should have called you.
That's 10 sets right there that I made.
Yeah.
I had a- I
Well,
had a
can I ask you, because I'm fascinated by this, like, what do you think just the wood cost on one set is nowadays?
I don't know. Well, that was everything because I put that whole order together. That was like $1,600.
Yeah.
No,
But
that's
probably
not
like,
crack.
but would you say like maybe $100 or more just in wood, just for one set, something like that?
Yeah, because a sheet of plywood's like $80 now,
Yeah.
and that
Wow.
doesn't include the side rails if you make them out
Yeah.
of
And we're not
steel.
talking about any plywood. I mean, generally speaking, the top surface has to be really smooth, right? You're not getting
Yeah.
you're not buying the janky stuff.
No, and I bought birch. I had them buy birch
Oh, wow.
plywood, and even that wasn't the best stuff.
Yeah.
And but it worked.
We might be
Yeah,
struggling for birch now. Most of that comes out of Russia. The Baltic
Well,
birch, anyways.
Baltic birch.
Yeah.
So that's why the poplar prices have skyrocketed. So if
Right.
you ever bought poplar in the past and you're buying it now, the problem is they're substituting the poplar for the Baltic birch, and
Yeah.
you can't get that. You know, it's crazy. So,
Yeah.
but yeah, I had
Oh.
to make 20 boards for a cornhole tournament for the PTSA.
Aha. That's
That's
really
how
cool.
that's how that ended up.
And you're using a laser for the words here?
Actually, yeah, my principal has a laser at home, and he has a different laser than what we have at school because we can't put a big sheet like that in the laser at school. He took it home and he engraved the logo on the faces. Like he did a real shallow engrave, so it literally was just a burn. And then on the back pieces, which I don't know if there's a photo, but there's actually we put the
Oh, there it is.
you can see it in
Yeah.
that one, yeah.
Yeah.
We put our logo on the back of each one.
Oh,
Oh, that's really
Now, you're probably wondering why does that one have two holes? Well, we're using our
I didn't even
CNC.
notice.
Yeah, we were using our CNC to figure out how to cut these holes. Now, any other person who does CNC work would probably say, well, that's super easy. You just do this, that, and the other thing. But we got our CNC right before COVID hit, and we haven't had a chance really to play with it. So we're trying things that are easy for some, but guys with no experience are struggling with. So we were trying to get the hole in the right spot, and these were just some offcut pieces that we had, and I was using them as like gluing because I glued the frames together first, and then I screwed the tops to them so that
Wow.
the frames would have been secured, and I could have made sure they were square and all that. So I was
Yeah.
just using them as like gluing blocks, if you will.
Yeah. Wow, that's really cool.
awesome. So pretty cool, yeah. And also he's doing some river stuff, that's popular now.
Oh yeah. Wow, look at that.
Mm-hmm.
Yeah, if the kids want to do that, they have to supply their own resin, and then they can do whatever they want. Usually, if they buy their own resin or they bring their own resin in, I have woods, kind of scrolled away at school that they could use, and we can look at and do some different things with. I always try something different. I'm always trying to see something different that works and what doesn't work. And we've had a lot of success with some things and, some failures with others. And I guess that's just what the whole education process is about.
Yes.
And, I'm learning a lot by the kids doing it. And you tell them you have to seriously mix it. And you tell them mix it for 5 minutes, but they don't mix it for 5 minutes. And then next thing you know, they're wondering why their epoxy's not cured. And because they didn't mix it enough, even though you told them 800 times you got to mix it enough.
Those
And then
lessons are best learned by the mistake.
Yeah.
I'm a firm
totally.
believer in that. Sometimes, as a parent, you're like, let him just make the mistake. He's really going to learn.
Yeah.
The unfortunate part is like you're spending $200-300 on epoxy, and you hate to see the kid fail.
Yeah.
And that's
but sometimes, that's how we succeed, through learning and through failure. We're being in the electric car field. This is kind of fascinating because none of my previous jobs or careers were anything like this because it's so new. And a lot of the stuff that we were doing, we literally didn't have a resource to pick up the phone to talk to. When we started building our performance EV, every single outlet that was in business for electric vehicles was focused on energy. And I'm honest, like there was just not a single person that wanted to talk about performance. And so we started to do our own experimentation. And one of the things early on that we did is we started doubting the kind of limits that were given to us. So in one particular example, the motor that we were using, it came with a hard like 140 volt limit. And you start asking around, like, what happens if you exceed this limit? And people, would give you any kind of wild story, like the motor blows up, you're going to arc, it's going to plasma ball, you're going to blow up the commutator. And we started doing some testing, and progressively you went 140, 150, 175, 200, in a scientific approach where we would stop, we would inspect the commutator, we were running temperature sensors and things like that. And we eventually took our voltage all the way up to 280 volts, double what they told us we could do without any damage. And that's how we ran our race car up Pikes Peak. Now, for people that know a little bit about electricity, your power is measured in watts, and which is like horsepower. And that's a product of your voltage times your amperage. And your current is really what you need to carry the fat cables for. It builds up heat. If you touch something electrical and it's hot, it's because it's carrying a lot of current. Voltage is different. You can run spark plug wires run at 50,000 volts, almost no amps. And of course, the wires run cool and everything. So just by us doubling that voltage, not trusting the data sheet, and actually let's with our own eyes and our own experience, see what we can do to this motor, we learned we could run it at 280 volts, even though everybody told us we couldn't. And now we could put, for the same temperature profile and the same thermal limits of the motor, twice as much power. And, we barely made it. Every temperature gauge in our car was like pegged in the red zone when we hit that summit 10 miles after the start, 14,000 feet of elevation, that's just mind numbing. And we wouldn't have made it otherwise. And so we started, we because so early on that was so profound for us, such a profound experience, we carried it forward, and we started testing that on some of the things that we were looking at to put in customer vehicles. Hey, let's test the limit of this battery. When we built one of the most fun things we ever did is when we built our Bonneville car, we didn't want to trust a data sheet. And so we took some batteries out back and we looked at what they were rated for current and time wise, and ran them at that. And of course they can do it fine because that's what's on the data sheet and they're being conservative. We started pushing this thing. We started purposely loading batteries and overheating them to the point where they were spontaneously combusting into fire. And by destroying a half dozen sets of batteries, we gained data that's invaluable, that nobody's going to tell you. And it was the only way for us to gather this data and for us to actually feel secure and safe that we can go to this race event, run outside of the limits. All these batteries are rated for a 1 full hour at this current. We're going to Bonneville. We only need 2.5 minutes, so where's that sliding scale in the middle? And this is kind of what I'm talking about. Early on, this information just wasn't out there. There weren't enough people running electric to share this kind of information. And I think we're still kind of in that era where there's a lot of experimentation. There's a lot more people involved in EV right now. It's become very trendy. And so there's a lot of information acceleration and really progression right now. But I think it starts with, people that are into this sort of thing, just knowing sometimes the best thing is just doing it, and learning as much as you can, not just, hey, let's go burn up batteries. I mean, let's take notes and times and temperatures and data. Ron just put up this a display, and it's got all our video overlays because we gather all this data. We've got our voltage, and we're even calculating the percentage of slip to the rear wheels, because you're kind of literally doing one long burnout from 0 miles an hour to 230 miles an hour, and so all this stuff, and you can kind of come back and crunch through the data, talk about it, discuss it, and the net result is have a better understanding of a field that really didn't exist just 10 years ago. And this
But
is
are you giving that information out to other people,
Yeah,
or
absolutely.
are you
100%.
just keeping it like proprietary to yourself?
No, because there's no proprietary here. We're enthusiasts, right? So, Tim, I invite you to come down, and there's a place for rent across the street. Opened up a shop. I'll come over. We'll drink coffee. I'll get you in business, and you'll be my main competitor. Because right now, you and our main competitor is gas. Straight up. I want to have an impact on this world, and I want to see change. I want to see progress. I don't want at the end of my life to see a lot of the things the same at the beginning of my life. And these are one of these things, like, we're here to inspire people and let you know, like, look, you can go out and have tons of fun. I mean, like Bonneville was one of the best experiences of my life. I got to be there with my father. I got to be there with my son. But at the same time, we inspired other teams. And in the following year, there was like 3 more teams that went out there and started doing electric, and we're just like, yeah, our work's done. We got people inspired, and they're doing this, and they're using our data. They're using our equipment in some cases. And to me, that's the goal. That's what we're trying to do, excite people to do this. Don't guilt them into it. Don't doom and gloom them. Be like, yeah, you've done a fat burnout in that car, but have you done one in an electric car where you maximum torque is at 0 RPM? Most people haven't, and that's something to experience, and it's exciting. And so that's what we want to build. It's excitement to get people involved, to play, practice, and it doesn't have to be an electric car. It can be an electric bike, electric scooter, electric go-kart, things that just have such an easier entry. There she is.
Yeah, I was just wondering just wondering what you were doing with that data. Like, a lot of people, like, if they're doing this research, they're going to take it, they're going to keep it to themselves. They're not going to give it out. They're not going to share it. They're going to just say, I did it, it's mine. And then, there's no collaboration there. But it seems like,
and I don't know the specifics of that situation, but in our situation, realistically, we're trying, let me do it a different way. If we didn't exist and you went out and built a Bonneville car and people saw it and were inspired by it, that's going to lead them to building their own projects. And we're an electric vehicle parts supplier. So one of the best things that we could ever have is a bunch of people out there building electric cars, trying to beat us, trying to do better than us, trying to do all this. Because at the end of the day, we have so much in common that we can use that to our advantage, learn from each other's projects, and build better stuff, even if, maybe our financial interests are different, or our business interests, or our brand, or whatever it might be that traditionally gets in the way. If you're trying to do something now with a tuner car, or a turbo, or whatever it might be, there's so many people in that field, and the field is so mature and so established. It's really competitive, but this is a field where you can talk to somebody who's brand new into it. They've only been in it for a year, and they actually might come up with some product ideas or engineering ideas that just blow away anything that you've seen in 15 years in the field. So, it's just an exciting time because of that, and so I think that's why, like, for me personally, I enjoy working with guys like Ron, who are really connected to the youth. And of course, Ron and I are working with the Electric Vehicle Learning Center. So I have to plug that ev-lc.org. We're basically taking a STEM programming and applying it to electric vehicles.
Yeah, we've got a class coming up on Saturday, and there is a father and son coming to the class, or actually it's a father and then their nephew or something like that. Anyway,
Yeah.
But yeah, so there's a 13-year-old coming to class, but the adults come to the class too, and the adults basically turn into kids, which is, it's funny. When I was doing these classes, I assumed that if someone was, let's say, an engineer, or they'd have some tech background, then I would insult them by having them do shop teacher experiments. And no, they had a blast, and so do I. So
right.
I think the shop teacher thing is good applied to this topic, because you kind of need an entry point. Everybody needs an entry point, and I think that I can attest, being a customer and a friend of yours, I think that you've 100% supported people that want to get into this. It's not a like, just order on the website. It's, I'll talk you through it. You need help, you want inspiration, whatever you need, we got you. Obviously you do have to learn a lot on your own. You got to do some experiments. And I would always advise someone who's starting out to start with a lighter vehicle. But I think people can do it. I think that you could do it individually, but I think you can do it in a shop class. You just got to think, how are you going to get it done in a year? This is school year.
Yeah. Well, and again, I think the answer there is, scale your project appropriately. You see all these guys and kids riding around on electric bikes now, go build one. That'll give you a sense of pride. I did a project real similar to that with my 7-year-old where we kind of did some battery stuff. We took the battery apart and we upgraded the motor. And I actually had him do most of the work. And, he'd look at me, Dad, I don't know how to do this. And hey, bud, one screw at a time, one fastener at a time, and when he was done, about an hour later, and he put the last screw of his last little body panel on the motorcycle, the pride coming out of that kid, man, you could if you could harness that energy, you could do something really creative with it. But that's, now he's like, okay, what's next? What's my next challenge? And I think, those are the type of kids that do end up in a shop class and go on to greater things. Ron inspired me yesterday to reach out to my old shop teacher. So, I think most of us, you go into a field related to this, and you don't forget your roots. You don't forget some of those things that initially really got you excited and attracted to this kind of work in the first place. And, that comes from these personal experiences that you guys are giving to kids. And you probably don't realize it. Like my shop teacher, in all honesty, was probably like, man, this guy cannot stay on one topic. He's all over the place. He's, and 20 years later, whatever, I'm running one of the largest electric vehicle shops in the States. And that's just fun, and so I guess what I'm saying to you guys is you might have a student that sits in the back of the class. Maybe he's not tuned in, but you're having an effect on him, and you're inspiring him in a way that might not even be evident for 10, 20, 30 years down the line. I got stuck in another career for 25 years before I was able to get into automotive and really work in my first love, so yeah, fascinating stuff. But I think really, a lot of that inspiration comes from you. And Ron and I have had some of these discussions over, the relationship with a shop teacher and inspiring, your students to kind of do this sort of stuff, build and be creative and learn.
Cool.
Thanks, guys.
Yeah, this is awesome.
Yeah.
Thank you.
Thank you to my shop teacher, Mr. Hammer. It's not a joke. It's true. Mr. Hammer was my shop teacher. And just amazing guy. Like I said, he taught it all, metal shop, auto shop. And there's probably, I had my father, but there's probably a pretty good chance I would not be here without shop class.
All right.
True. No, I mean, that's, this is easy to say because it's honestly true. I mean, that started my love for all of this. Yeah, my dad was great and everything, but like, we didn't have a welder. We didn't have a lathe. We didn't have a lot of the stuff that we had access to in our shop, and so that was, now I'm welding and doing all these things, and I could take my brake rotors off and actually turn them, put them back on, and do all these things. And my dad's like, "What? You're turning rotors? Wow!" And so it's so cool. All of that came from shop, and
Nice.
It works. Yeah.
Cool. Well,
Yeah.
this is
With
great.
that, I've got to check out. It's about
no
coming
problem.
up. Oh, hi, Matthew's got somebody in there in the
Yeah,
background.
this is while
So-
you're talking about it. I want
hi.
I'm on-
Sweet.
There you go.
This is Ira. She can't hear you guys. Hold on. Let me turn off my headphones here. You were talking about doing things with. Can you guys hear me through the phone?
Yeah.
Yeah.
You.
Okay.
Yeah.
So Ron just showed. So This is Iris. This is my stepdaughter. We've been working on projects. She's been doing all the handyman projects around the house with me, which is great because I hate doing stuff around the house, and so she takes care of it all for me.
Does she do? Will she come to the West Coast?
Say that again.
I said, is she willing to come to the West Coast? We have some walk around. I saw her form. Look at that, driving the screws all the way in. Wow, amazing.
Those were the steps. Hold on a second here. I'll mess with it. We can barely hear you guys, but those were the steps that go to the building trades house. And then she's fixed the door, she's fixed the gate. What else have you fixed, Iris? What else?
Ceiling.
Oh yeah, we patched some drywall on the ceiling.
The drywall.
Oh my gosh, Iris, I am so impressed. How old are you?
11.
Oh my gosh, I am so impressed. I'm going to show this to my son. This is amazing.
Yeah, so this summer I don't have a lot to post on my Instagram because I'm not at the building trades house. So we have a honeydew list that's overdue and way too long. So
She doesn't do anything around the house.
she's ratting me out.
I mean, I'm sitting here watching her outshim you, Matt.
Yeah. So I literally show Iris what she has to do real quick, or tell her what she has to do. Sometimes I don't even have to show, and then she just does it, and then we videotape it, and then she talks about what she's doing, and that's it.
Truth comes out, Matt. Truth comes out.
Yeah.
Right? No, I'm very truthful about this. I hate doing work. I love doing work, but I hate doing work at home. Right? We all, right? The cobbler's kids or whatever, shoe cobbler's kids have no shoes, whatever.
Yeah.
That is the truth around here. So, Iris has been doing a lot of home maintenance, and when she gets done, she always says, "What can we do next?" or "What needs fixed next?" So that was kind of the hashtag, and so that's what we've been doing this summer.
Sometimes it's easier for me to take stuff to school to do it than it is to try to do it in my garage. Like, I have an air compressor in my garage, but it's easier for me just to put whatever I need to do in the bag, take it to school, blow it out, and then bring it home. It's just easier.
Well,
Cool.
Listen, I apologize. I have to run. Tim and Matt, it was a real pleasure meeting you guys. And Ron, thank you for being such a gracious host and inviting me onto your program. I had a lot of fun and would love to do it again. And thank you to all the viewers and the listeners for tuning in. Very much appreciate it.
All right. Thanks, Michael.
All right. You guys take care. We'll see you next time.
Bud. Later.
Okay. So that was pretty cool. So I could do a little bit of a tour, a little bit show some of the shop around here, and then we can kind of wrap it up. You guys have more time or not?
Yeah, I mean, I have a couple minutes.
Okay. Let me do that.
Now, you've broadcasted from here before, right?
Yeah.
Yeah.
Okay. I'm going to get you on. You want to jump on?
Oh, I was on the thing.
Oh, yeah.
Finishing our
Okay, no
those are
problem.
my arrival shots. Hey, good morning. How are you?
That's funny. This. Oh, go ahead.
All right, we're gonna do a different setup.
Okay, I'm gonna see if I can do
Just
this.
gonna have you walk in from this direction.
Hold on 1 second. They're shooting a TV show right out here.
Nice.
Yeah, it's wild. Hold on. Okay.
Hey Tim, did you see that Char that we've had on here before was with this old house with Tom Silva and stuff?
I saw that.
Crazy.
We got to have her on again. We got to get her back.
She's so good. Like, in fact, actually, I need to get a hold of her because I know she's in Atlanta, and my oldest stepdaughter's gonna be going to school in Savannah at SCAD, and not that I think they're still a few hours apart there, but I also have a cousin lives in the area and a fraternity brother and wife, and we're trying to get our closer local connections for made in case there's any. Yeah, we can hear you, Ron.
Yeah. I think they're a while away from each other.
I think it's still like 3 hours or something.
Yeah.
That was great.
Yeah, we should reach out to her
Don't
and see
worry,
if we
they
can get her back
can
on
just see a
again.
little
That'd
bit.
be awesome.
We need to get her to get Tom on here.
Oh, that would be awesome.
She said he's really cool and down to earth, which I mean, I that does not shock me by any means. And then I know And then I actually know one of the other new guys. I can't think of his name offhand. I was with him when we were down in the Build Show and down in Florida.
Yeah.
He's been on there talking about like air quality and stuff, and I can't think of his name, but I am connected to him, so maybe he could help us out there too and stuff. So yeah,
I would love to talk to Tom. Have you follow his daughter on Instagram?
Yeah, they're funny.
Yeah, they're
Getting him to
pretty
do like all the TikToks and stuff. Yeah.
I think she pushes him out of his limit a little bit. So.
Oh yeah. But he does good with it. I mean, he's like perfect because it's like the innocent, kind of like the innocent grandpa doing all the TikToks.
Yeah, maybe if we have a lead in with Tom, maybe we can get Norm.
Yeah. Oh yeah. Because he just retired.
Yeah, he's gonna retire. Retired.
Yeah.
That would be awesome.
That would be a show of all shows for the Shop Class podcast.
That would be bigger than the Jimmy DiResta one.
I was gonna say that'd be about the only way we could get bigger than Jimmy DiResta right now.
Yeah. Getting Norm on there. I would say also Mike Rowe, but
yeah.
I think that's the GOAT of this.
Yeah.
Hey, we're gonna kill the recording here. Shop Class Podcast. Thanks for tuning in, and we'll see you on the next one.
Thanks for tuning in.
Come on, we were having a good side conversation here.
Oh no! I'm gonna stay, but we're gonna kill the recording.
No, people want to hear that.
Oh.